Hey everyone, welcome to Grade Gain, where every student can make progress. We're going to be looking at another required practical today. This one is a chemistry one again, so don't forget guys, safety first. Got to wear your safety specs, okay, so we'll be wearing those throughout. What we're going to be doing today is we're going to be looking at electrolysis. Now, as always, the instructions are downloadable from my web shop, so check it out. Make sure you get that, the link is in the bottom on the comments as well, so you can download that and you can follow this through as we go along. Now, with electrolysis, what we're going to be doing is we're going to be splitting up some compounds into separate elements. And we're going to be doing that using electricity. We've got 4 different compounds that we're going to be working with today. First up, we've got sodium sulphate. We then have sodium chloride, copper sulphate, love the colour of this one, it's a beautiful colour, and copper chloride, which you will notice is the same colour. Okay, now we also need to make sure that we've got a beaker. We're going to be using some blue litmus paper. Now we need the blue litmus paper to enable us to test to see if the product that we're getting is an acid. Blue litmus only tells us if it's an acid. It doesn't give us an indication of the pH. For that you would need universal indicator paper. Okay, so this blue litmus just tells us if it's acidic. We're also going to need 2 carbon electrodes. Now we have very cunningly modified a crisp lid. We've used Pringles. Many other types of crisps are available, but I had to eat these, so I went for ones I liked. We've modified a crisp lid to put the 2 electrodes through. There are our carbon electrodes, okay? And we're also going to be using a lamp and our faithful trusty power supply. So now we've had a look at that, we'll get it all set up and we'll look at what it looks like when it's set up. So here's the equipment that we need: our power supply, our wires, our lamp, our electrodes and our beaker. We're just going to connect up the circuit. Remember, always start at one side of the circuit from our power supply. We go to our lamp. From our lamp we come round to our electrode, and then from the other electrode we return back to the power supply. Now we should see that we have a complete circuit. Now if we turn this on, remember we don't want anything more than 4 volts, so we've got to check that we're on 4 volts on our power supply, and then we can turn it on, make sure that we're on 4 volts, and we can see that we've got nothing happening because we have got no complete circuit. We're now going to add our liquid and see what happens. We've now added our copper chloride solution into the beaker. We can see that the electrodes aren't touching. They're well apart from each other. If we turn the power supply on now, we can see that we've got a small current flow, as signified by the lamp coming on. If we look really closely, we can see that we've got bubbles being given off from this electrode. Now this is the positive electrode. Positive electrode is known as the anode. If we look closely at both electrodes now, we can clearly see the bubbles coming off the anode. And if we look closely at the cathode, we can see that there is a slight change in colour. To help us work out what's going on, we're going to hold our blue litmus paper next to the anode and see whether we can see anything happening to it. If you look carefully, you can actually see that it's starting to change colour. It's bleaching slightly. So we can see lots of gas being given off, and actually this is a great image for refraction as well, showing what happens when light enters different densities of materials. But if we now turn the power off, lift out our electrodes and have a little look, we can see quite clearly that this carbon electrode is coated in a copper-like substance, and it is in fact copper. And now we're going to repeat this with our copper sulphate solution. We turn our power supply on, our bulb is now on, and we watch carefully. So looking carefully again at the anode, we can see a gas is clearly being given off, loads of bubbles there. So let's test that gas. Let's hold the litmus paper in there and see what happens. This time we can see that it's having no effect on the litmus paper at all. So that tells us that we've got oxygen being given off. If we look carefully at the cathode, we can clearly see we've got copper being deposited on there again. It's fantastic, lovely colour. And now we repeat with sodium chloride. If we look at both the anode and the cathode, we can see that there is gas being given off at both. The gas being given off at the cathode, that's this one here, this is hydrogen. There's not enough of it to test. If we look at the gas coming off at the anode, we can test that again with our blue litmus paper. So we will slide that in and see what we're getting. So we can see that this is bleaching the litmus paper, so we've got chlorine gas being given off. And if we look at the two electrodes, we can see that we've not got that lovely coppery deposit anymore this time, because we were getting hydrogen given off instead of a metal deposit. So our final solution for today, the sodium sulphate, we can clearly see the bubbles coming off both the anode and the cathode. Let's test the gas at the anode and see what we've got. Holding the litmus in there, we can see that nothing is happening, got no colour change. So we've got oxygen being given off and we've got hydrogen being given off at the cathode. So we've been able to split hydrogen and the oxygen out of the solution. So in summary, we can see what we've got given off at each of the electrodes. So at the anode, for copper chloride, we got chlorine given off. For copper sulphate, we got oxygen given off. For sodium chloride, we got chlorine. And for sodium sulphate, we got oxygen. On the cathode, we got copper from copper chloride, copper from copper sulphate, and then for the sodium chloride and sodium sulphate, we got hydrogen. Now the hydrogen has come from the water because these were aqueous solutions. The reason that we get the hydrogen, not the sodium, is because sodium is incredibly reactive and stays in the solution and the hydrogen gas is given off. So there you have it. We've seen what happens when we run electricity through those aqueous solutions. Remember, aqueous means dissolved in water, and the reason that we can run electricity through them is because we have ions or charged particles in those solutions, and those charged particles move to the opposite electrode. So the positive ones move to the cathode the negative electrode, and the negative ions move to the positive electrode, the anode. Okay, so hopefully that's explained required practical for you on electrolysis. Don't forget, subscribe to my channel. Maybe watch some of the other videos. I've got a really good one on Newton's laws. You want to check that one out if you can. It's going a little bit viral. Leave some comments, give me a thumbs up and a like, and good luck with your GCSEs.